Okay, so here's the two object problem. So we've got two particles in this question. So we've got a surface, and we have got point A, and it says that particle P passes through A with a velocity of 2.8 meters per second. Okay, but particle Q is going to pass through 3 seconds afterwards with a velocity of 2.4 meters per second. Okay, and constant acceleration is 0.2. Right, so we need an expression for the displacements of P and Q from A in terms of T. So we need displacement. So we've got a diagram. Okay, we're going to resolve in this direction because that's the direction both particles are moving in. So now we know that S, U, V, A, T. Okay, so let's say for P, do P first. For P, we want to know the displacement. Okay, we do know the initial velocity, that was 2.8. We don't know the final velocity, we do know the acceleration, that's 0.12. Okay, and then we need, it says in terms of T. So this is just going to be T. So what equation do you use? Well, let's use S equals ut plus a half at squared. Okay, so that means that S equals 2.8 t plus a half times 0.12, which is acceleration, which is just 0.06 t squared. So that's P. Okay, Q, we're going to use the same equation. So S is going to be equal to 2.4, which is our U, the initial speed, times our time, plus a half times our acceleration, which is 0.2. That's 0.1 times t squared. Now, what we're trying to do is find out where they are at any instant. Okay, we want an instantaneous view of how far they've travelled. So now, t is basically the time that P passes A, and we want the time after P passed through A. So basically, Q doesn't pass A for 3 seconds. So any point afterwards, it will be 3 seconds behind P. So we have to say T minus 3. So the elapsed time, the amount of time that's passed is 3 seconds less for Q. Okay, so that's A taken care of. Now B, we've got to show the particles meet at 2t squared minus 50t minus that. Right, okay, so that's A taken care of. B, if they meet, that's got to mean that my two equations are equal to each other. So that means that 2.8t plus 0.06t squared is equal to 2.4t minus 3 plus 0.1t minus 3 squared. Okay, now I've got to try and simplify that equation. So first thing, let's expand this out. So 2.4t minus 7.2 plus 0.1t minus 0. Oh, sorry, let's go there first. We have 0.1 times t squared minus 6t plus 9. Okay. then I take that out, collect my terms together, and I'm going to take away 0.1 t squared, and I get 0. Over here, I get 0.04 t squared minus t minus 6.3, and I have nothing left over here. Now, it says that I've got to match this quadratic. Well, that doesn't match, does it? So let's look at the t squared. What 0.4 times what is 2? Okay, so if I multiply that by 10 or 100, so it's going to be 50 times that. Okay, so then if I do 50 times, remember it has the same solutions, I get 2t squared minus 50t minus 315 equals 0 as required. So that is my part B. Okay, remember just by multiplying by 50 and the solution's not changing. Right, now and find distance from A when the two particles meet. So now that means all I've got to do is go back to A, sorry, to P, because that's a simple one, and substitute in the time that I found. Okay, so I know that if I try and solve my equation, so I've got 2t squared minus 50t minus 315 equals 0. And the two t values I get from this are 30.21 and negative 5.21. Well, we all know we can't have negative time, so let's cross that out, make it clear that's not a solution. We know this is the only solution. So now if I use S equals ut plus half at squared, I can substitute in that 30.21. So my displacement equals the initial speed for P, which was 2.8, times my 30.21 plus a half my acceleration, which was 0.12. And then I have my 30.21 squared. And that tells me that my S is 139.36 meters. Okay, remember this was for P. I could do it for Q. Okay, then my distance would be my initial speed, which was at this point 2.4 times. Now remember, this is T, so for Q it's going to be T minus 3, so that's 27.21 plus a half. Now the acceleration for Q is 0.2, and then again 27.21 squared, and I get the same 139.4 meters. So that takes care of C.